Welcome to Forging the Future, Decarbonizing the Steel Industry, a Hatch podcast series. I'm your host, Takshi Sachdeva, and invite you to join us on a journey through the challenges and innovations in iron and steel production. Discover how Hatch's century of expertise is shaping a sustainable future for the steel industry. Stay tuned as experts from Hatch share their insights on technology, market dynamics, and the path to decarbonization. Welcome back to Forging the Future, Decarbonizing the Steel Industry, the podcast where we discuss the latest in sustainability and innovation in the steel industry. In our last episode, we discussed on the peripheral implications on iron unit supply with the massive shift in technology occurring in the steel industry, and what happens to the global market for scrap and virgin iron units when the dominant steelmaking technology is no longer a blast furnace. In today's episode, we're continuing the conversation with 4 Hatch specialists. I'm joined with Martin Dionne, Global Director, Iron Ore, Stefanie Vo, Senior Iron Ore Process Engineer, both based in our Montreal office, Bruno Vartuli, Regional Ferrous and Light Metals Director for South America from our Bello office, and Jeanne Els, a Senior Consultant to Iron and Steel, joining us all the way from Australia. Welcome to the show, everyone. It is a pleasure to have you all on board today.
Thank you, Takshi, for having me.
Hey, Takshi. No, thanks a lot. It's my pleasure to contribute on this.
Hey, thank you very much for having me.
Actually, it's great to do a podcast with you today.
I'm really looking forward to our discussion today, and I'd like to start with Martin, who's been heavily involved in the iron ore industry here in North America. So, Martin, your opinion and based on your 15 plus years of experience at Hatch, how does the current economic climate affect where the iron ore industry is currently heading?
Yeah, look, if I take it from, I would say, let's say an high-level approach here, I think we can certainly all feel the pressure, as a company and individual and industry to really work and be up to the challenge to support and to achieve decarbonization of our economy. And certainly our industry is facing a lot of challenge, and the iron ore industry for sure is at the center of all this, as it is a part of the steel making value chain, of course. I think our industry will need to adapt rapidly. Of course, it is adapting, but I think we will need to increase the pace of adaptation. And I think there's some parallel that we need to draw with the manufacturing industry. That is doing this for decades and not a century now. They are very agile and adapt quickly to the trends, new technology, and also the market demand. So I think our industry has some inspiration to take from the manufacturing industry. Uh, Also, as you know, one of the challenge, of course, is the mines are getting depleted as we speak, slowly depleted throughout the world, and the grade, of course, is getting lower. And we all know that to achieve, the target and to support decarbonization of the steel value chain, we need some higher grade ore and some direct reduction grade, and that will certainly be a challenge. And the future mine, as they are getting depleted, these future mine will have to be built into a remoter location, and maybe as opposed to the past, where these mines were more accessible, I should say. They were more focused on the mining and the process, and of course they needed some infrastructure. That's for sure. But if you look around the world, as the location are remoter, the mining project became a massive infrastructure and a logistic project requiring a lot of capital. They're really capital intense. So that's certainly a challenge to finance these projects. And also, I believe in terms of trending, and we'll discuss this in more detail later on. But I think also there's in the past, I would say maybe 20 years, there were a lot of large project producing 50, 100 million ton of ore per year, and adding them up to billions of ton, for a different country. But I think also in the future, there's room for a smaller mine, 20, 30 million ton, with and developing some magnetite deposit as well. So I think it's one avenue for the future. And of course, all this is connected to the DRI technology, direct reduction technology, that need higher grade ore with less gang. But this will certainly be a bottleneck. The availability of the DR grade concentrate and the DR grade pellet will be a bottleneck to the rollout of the DRI technology. There's some good news, though, for sure. There are, I would say, avenues, new process flow sheet, new process technology that are being developed at the moment. And all this, I think, we're looking at this. We're very enthusiastic, to be participating in developing and innovating on the R&R side to support the greener steel production.
Thanks for sharing that, Martin, especially highlighting some of the challenges that you're facing, well, that the industry is facing, and more so your clients in the iron ore business are facing. I'd like to move on to Stefanie. So Stefanie is someone with considerable experience working more upstream on the iron ore processing side of things. In your opinion, how is the North American region handling with some of the challenges that Martin emphasized on?
Yeah, thank you, Takshi. So the North American context is very specific and different from others. So North America produced about 115 million tons of iron ore in 2023, 70 million tons of which in Canada and 44 in the US. The main difference we have is the ore body. It's hard rock deposits, mostly hematite magnetite, and it's considered lower grade, if I can say so, around 20 to 40% Fe. It responds very well to beneficiation, so the run of mine needs to be processed to reach a sellable grade around 63 to 65 total iron. So the main advantage of the ore in North America, it's its liberation capacity. So it liberates very well. It very low content of detrimental impurities, let's say like sulfur, phosphorus, and others. But of course, it needs to be beneficiated. So we're talking here about crushing, grinding, separation, whether it's gravity separation, magnetic separation. And this process requires resources. So water, energy, consumables. And as Martin just mentioned, it generates tailings that we need to manage. So those are sort of the challenge we face in North America.
And based on what you just said, I mean, the topic or the general theme of this podcast is decarbonizing this industry and kind of diving deeper into that. How do you think these iron ore producers can contribute towards lowering their emissions?
They can contribute in many ways. So let's say we look at a higher level for the operators. The first thing is increasing beneficiation of hematites to produce high purity concentrate. So what we call DR grade also. And the second one, it's applicable in North America, but also a little bit everywhere. We have to focus also on magnetite. The run of mine responds very well to magnetic separation and beneficiation, and can provide part of the answer for increasing the DR grade iron ore supply that's required right now in the world. If we look more at the operations level, so scope 1 and 2 emissions reduction, we're talking about very innovative things we're talking about. So electrification of mining operations, in-pit crushing to minimize everything that's truck fleet and fuel consumption, improving iron recovery at the concentrator level. So automation, digital, AI technologies that are very new also, improving induration machine efficiency through improved design and control, something that's very new and starting to take more place, maximize the use of bioenergy, so biomass, pyrolysis oil, etc., and maximize use of solar and wind energy with storage capability and receiving heat where it makes sense.
Yeah, Stephanie, that's thanks for sharing this. One thing that I would like to add also, you've mentioned about the I would say alternative source of energy like pyrolytic oil and others. And for sure there are some other type of energy that can be used. I'm thinking in the induration machine as well, like radiant tubes as well as plasma torch. But I would like to bring something, also, and we're hearing more and more about this, but about SMR, and I think these modular nuclear reactor, the small modular reactor, nuclear reactor, sorry. I think we need to explore these avenue. I think this is an interesting path. Of course, we need to be mindful that it is complex, and also there's a lot of factor to account for implementing these SMR, like the seismic region. You will implement them, but still, I think they're part of the future to greener steel production.
So thank you, Martin. And one interesting in Canada and Quebec is that the government recognized high purity iron ore as part of the critical minerals list that's required for the path to decarbonation. So this allows us to put a spotlight on the Labrador Trough. It's high quality iron ore. And we believe that for that region and the specific context of the Labrador Trough, it makes so much sense to target producing DR grade. It's not the same context worldwide. My colleagues will touch on it a little bit after, but for our region, that's where it makes sense.
No, I'm glad you highlighted that each region will have to develop the solution that works for them. And like you said, we'll be diving deeper into that because we have Bruno and Jeanne joined us today. But as for North America, what do you see as some of the headwinds for project execution?
Yeah, so that's a good question. So for the area we're focusing on, so Labrador Trough and the Arctic, the main challenges, of course, infrastructure, power availability, rail capacity, skilled workforce availability, and one of the major ones that's sometimes we don't consider as critical, everything that's environmental and sustainability, and also involvement of communities at early stage of development of these projects. So those are all critical enablers for the iron ore industry in Canada and to help go forward in the green steel path.
And how is Hatch kind of approaching tackling these issues? Martin, would you like to expand on that?
Yeah, sure. I mean, the honest answer, and I think it's the only answer, is to work to communicate. Through our environmental group, and as well as our community engagement group. We're close to the different region. We're close to the different authorities, and we're part of I would say, an honest and transparent communication with them, involving them, of course, at the early stage, and of course, it's partnering with our client. I think it's the key here. So, in order to achieve deliver a successful project delivery, as Stephanie mentioned, we need the buy-in and the implication and involvement of the different communities. And we can only achieve this by working together, as partner, and building trust and communicate at each step of the project development.
Yeah, just to add in, I think we've seen for the Labrador Trough, I'm very passionate about that region. We've seen a lot of collaboration between the operators that are located there, a lot of talk with the government, a lot of discussions that allowed us to bring iron ore into the critical minerals list. And I think that collaboration goes larger than just these operators together. It's all the consultants, the OEMs, engineering firms working together with the common goal of the decarbonation of the iron ore and steel industry.
Yeah.
Absolutely. Now, thank you for adding in on that. Okay, so if I may, I'm gonna fly over to Brazil to Bruno here. Bruno, you've worked in several different commodities over the course of your career, different countries, and from what I understand, executed projects in all different continents over the past 25 years. You are now the Ferrous and Light Metals Director of the South American region for Hatch. Is South America facing the same types of challenges as highlighted by Martin and Stephanie?
Yes, thanks for asking, Takshi. Of course, it's a global issue, as we know. There is a big difference between South America and North America, and of course to the Western Australia, which will be addressed by my colleague Jean. So as you know, the ore body in Brazil, it's about 40, 55 to 65 content of ferrous with a very low detrimental impurities. This is a great economical advantage for Brazil. So we can explore that. We've been exploring this in terms of the low cost of production, as we've been supporting the clients also in the iron ore, but also in the iron steel industry here. However, there is a big concern in Brazil production of the DR grade pellets, which is a very small part of the production. It's about 10 to 15%. In the big picture, just I think it's very important to position ourselves. Our production last year was about 440 million tons of iron ore. It's a slightly half of Australian production. But as I said, 10 to 15% only, it's DR grade pellets. So this is a big challenge for the Brazilian industry, and most of the iron ore producers in Brazil are focusing the initiatives on creating value, finding solutions for the briquetting processing route. So one of the major producers in Brazil, it has initiatives of creating hubs all over the globe to make sure that their product, the iron ore, is being used for the green briquette as we say, as we see in the market. So to some extent, the challenges are very similar globally. So our iron ore producers, they're facing the same issues. They need to position themselves as a very good option in dealing with the Scope 3 emissions and developing, as I mentioned, the beneficiation flow sheet that can be used in all the greener steel making technologies. So once again, to some extent, these later challenges very similar to the Pilbara iron ore producers. They're very similar to what they're facing with new technologies, new products, and new challenges.
Thanks for elaborating on that. And I think that's a great segue into Jean's area of expertise, which is the Australian iron ore landscape. Before we dive any deeper, Jeanne, you're based in the Hatch Brisbane office. Would you like to brief up our audience with the iron ore landscape in Australia?
Of course. So first of all, most of the iron ore activity in Australia is on the west coast and southwest coast of the country. Australia is the largest exporter of iron ore in the world and currently exports roughly 1 billion tons of iron ore per annum. This is mostly goethite and hematite. There's also some magnetite being processed. Interestingly, Australia has extensive magnetite reserves, but because it's so easy to process goethite and there's such a large market for it, it's not really necessary to invest in expansion of magnetite capacity. The Australia Pilbara is called Pilbara blend. Commonly has been home to the blast furnace production route, which makes up, I think, in previous podcasts we've spoken about this extensively, up to 70% of global production globally. Now, because of the shipping routes from Australia to Asia, it's a perfect route to service all of this blast furnace production that happened in Asia. And the logistic chains, you can imagine the logistic chains required to move 1 billion tons of iron ore globally every year. It is absolutely significant. Now, the blast furnace producers locally are obviously working with, the iron ore producers locally are working with steel producers in Asia to support the transition to greener carbon-free technologies. Obviously, as with any producer, it's really key to keep pace with the market. And the Pilbara producers are very, very aware of that, and they're very proactive in working with their customers to transition as that technology transition happens. As I mentioned, there is a little bit of magnetite being mined for both local consumption and export. But as we see the shift towards DR grade and the requirement for more pellets globally, we're definitely going to see more activity.
So I'm glad you touched upon some of the decarbonization initiatives that the Pilbara miners are taking. Are there any challenges that they're facing, and perhaps how is Hatch or your team in Brisbane assisting them?
I would say there are two large themes. The first theme is improvement of quality of the current production. And the second key theme is addressing Scope 3 emissions. Generally speaking, high-grade Pilbara, such as high-grade lump and low phosphorus deposits, are being depleted. This was traditionally exported to Japan. Most of the mines now has higher phosphorus, and that's actually creating significant blending and logistics challenges. And again, the logistic chains have been set up to create this blend of product. Many of the mines are below the water table, and that results in goethite being mined. Now, consistency of grade, specifically making sure that phosphorus and gangue remain within a tight band, really contributes to the reduction of emissions on the on the traditional steelmaking route. So there's a significant emphasis on improving the quality of the product or tightening the range of the impurities. And then secondly, in parallel, the significant investment we're seeing in just keeping pace with business as usual, where new mines are being opened up to replace current mines that are being depleted. We are obviously helping the Pilbara clients in a number of areas on the logistics and mining side. On the second theme of Scope 3, focusing on Scope 1 and Scope 2 is just not sufficient, because that makes up less than 5% of total CO2 emissions in the blast furnace route. As such, the iron ore producers are doing significant development work to address Scope 3. There are unprecedented things happening in industry at the moment. A recent MOU was signed between BlueScope, Rio Tinto, and BHP to specifically look at the development of a pilot furnace to develop a low emissions iron making route that will process Pilbara ore and other low grade ores around the world. And I'm sure that will be visible in other places as well. For Pilbara, their customers are transitioning away from the blast furnace route. This is not going to happen in the next 5 years. It's a multi-decade program of works that are happening. And the critical thing for the Pilbara iron ore producers to remain relevant at scale is to transition with their customers as it happens. So therefore, just as with a Rio Tinto BHP BlueScope initiative, the Pilbara producers are investing in supporting the development of low emissions technologies. Now, in addition, the previous podcast mentioned the shift in raw material requirement, and that theme is playing out here in Australia as well. The trend is visible in traditional Pilbara producers, like, for instance, FMG, that is invested in the production of magnetite as well as part of their product routes. But then also, as I mentioned earlier, there's significant work being done in developing mines and production routes to leverage this rich magnetite bounty that we have here in Australia, and we're supporting a number of clients in that.
Now, thanks for sharing those details. I think we can all agree that steel is there to stay and is in fact a critical metal, and essentially required for decarbonizing our future. Hatch certainly has all the capabilities to support the innovation and a cost-effective implementation of these greener projects. As we near towards the end of our episode today, do you have any key takeaways for our audience tuning in?
Thank you, Takshi, for that question. I think when people think about decarbonation, we often jump to the classic ones like lithium, nickel, cobalt, and we forget that iron ore is a part of it also. We have a key role that we can take in decarbonation of the iron and steel industry, and it starts with iron ore And in North America, it starts with the DR grade high purity iron ore. So I think that's the takeaway I want people to leave with.
Thanks, Stephanie.
Yeah, I would like to add and pile up on Stephanie and about the beneficiation and DR grade. From my perspective, one takeaway when you look at the requirement of iron ore from all the industry, we talk about Brazil, and then Australia production. It's more than 1 billion ton per year. So from my perspective, there's no way we can beneficiate, using, I would say, the traditional route, using water, that amount of energy to beneficiate 1 billion ton of ore. I'm taking the example here of Australia, the production of Australia. So there has to be other way, other technology to process that ore, the lower grade ore, and make and produce greener steel. And of course, as Jeanne mentioned, there are a lot of I would say R&D throughout the world by different tier one companies and also at different universities. So which is good. And I think one of these avenues certainly the smelting route, where you can use lower grade fine ore through a smelting furnace. This is one example here. So I guess it's really important, that we develop a new technology and innovate, because there's no room on environmentally speaking, to beneficiate and bring all the ore to a DR grade level. Um, and also, I think I've touched this one crucial thing is, of course, we will need to find ways to produce hydrogen. Hydrogen is also at the I would say the cornerstone, or at the center of all this as well. So we need to develop technologies to produce hydrogen at a lower cost, and it won't be easy. It will be very challenging, but of course we're up to this challenge. That's for sure. And I believe I did mention this as well. I think there's we thought in the past about, I would say, large facility and massive production, but I think now, given the current context and as per country context, where there's green power available and less green power, I think there's room for smaller operating our facility, and some of them will be beneficiating the ore, other will not, and will go through different processing route to steel making. And also, I think one key avenue to minimize the consumption of water. I think still water is key here, because not everywhere, of course, there's water, and I think we'll need to emphasize or focus on the development of dry mineral processing route. We kind of there in the past, it was developed. There were some dry flow sheet, but they were kind of not forgotten, but put aside and we're using now, of course, more the wet route. But again, it's water consumption intensive, if I should say, and also energy intensive. So we'll have to develop dry mineral processing route in the future.
I think I'd like to add a steelmaker's perspective on this. The steelmaking route has been the same for centuries. It's been the dominant route. And it's at times like this, when different drivers come together, that significant technological innovations happen. So I'm excited to see what is going to occur, because similar to the challenges that Martin mentioned, it's not that straightforward to take a technology that has been honed over such a long period of time and been made extremely productive and replace it with a new technology. And that's going to need scientists, engineers, operators to come together to make it happen. So I'm excited to see that starting to occur.
Thanks, Takshi. Just connecting to what Stephanie and all the colleagues, Stephanie, Martin, and Jeanne, just mentioned, I believe there is an element of innovation, like Jeanne just mentioned on the discussion. And that's very exciting, especially for the new generations that are looking for challenges and a purpose in terms of the work. So the innovation will be the key because we have a lot of technologies. We do the dry process, mostly dry process is the major mine in Brazil, which is great. Of course, we have room to expand that. But we need more. We need more. And the more we develop the technologies for batteries and electrification, the more we depend on steel and the more we depend on iron ore. So it's a paradox here. To build battery factories, we need steel. To build electrified trucks, we need more steel. They're heavier. So the structure changes. So we have a saying in Brazil that the steel is the second best friend of the man. The first is the dog, the second is steel. It tolerates a lot. So I think there is a lot of exciting in the industry here. Iron ore industry, steel industry, infrastructure industry. And hopefully the next generation of the scientists and the experts will be helping us to get there on this long run. Thank you.
Absolutely. Thank you. Thank you, Bruno. I think I couldn't agree more. I think as someone who's 4 years into my career here, it excites me to truly like work on something that I can see have a long-term impact. So I appreciate you bringing up that point. And on that note, thank you all for joining us today and sharing all the interesting work you are doing in the industry, and presenting Hatch's iron ore capabilities and experiences with our audience today.
Thank you
Thanks.
for having us.
Thank you.
Thanks so much, Takshi.
Thank you for joining us on Forging the Future, Decarbonizing the Steel Industry, where we navigate the complexities of iron and steel. We hope today's episode has provided you with valuable insights into the sustainable transformation of the industry. Remember, the path to decarbonization is a collaborative effort, and every step counts towards a greener future. I am your host, Takshi Sachdeva, and along with the entire team at Hatch, we appreciate your engagement and curiosity.